Hi, everyone. I'm David Tasker. Adisyn has announced a major milestone in the development of its graphene semiconductor technology, successfully scaling its low temperature deposition process from a 1 square centimetre sample to an industry standard 200 millimetre wafer. Joining me to discuss the result is Adisyn Chair Kevin Crofton. Kevin, thanks for your time.
Hi there, David. Thank you for the invitation. Much appreciated.
Let's start with the headline. Adisyn has deposited graphene on a full 200 millimetre wafer. In simple terms, what has the company achieved and why is it significant?
Yeah, thanks, David. I think in your prelude you mentioned that we had done work on a coupon sample. We've run hundreds of coupon samples, and to get to a baseline process regime. If I reflect back on where that was, we weren't sure what the scaling capability was. Some of us were maybe on one side of the spectrum and others were on another about how scalable this is going to be. Um, the team, we made a decision to go and run a pathfinder, as we say in the press release, a pathfinding 200 millimeter wafer. So it's a first off, one of its kind, basically as a ranging shot to see where this process might have its boundary conditions. And it's quite remarkable. I mean, I can't understate what the team has been able to accomplish to go from a 1 centimeter square coupon to running it on a 200 millimeter diameter wafer format, which is an industry standard format. Everybody recognizes 8-inch, 200 millimeter. To be able to do that on a single first shot pass, no matter what the quality of the film might be, because we don't know yet, just to be able to do that and say we've got what appears to be a continuous graphene layer across the entire diameter in every direction that you could look at. It's incredible. It has not been done in the industry as far. Well, I can tell you from you literature search, any tool that you use to go and see, has anybody reported something of this significance? The answer is no. There's nobody that has put this out there, whether they're competitors or whether they're potential clients. So it's a major step, and I just do not want to understate how important it is. So in simple terms, we've been able to put down a, an identifiable graphene layer across the entire diameter in any direction that you can imagine at this point. At least that's what the data show. It allows us to go and talk about scaling the process, making sure that it's repeatable, making sure that it's uniform, making sure that it has the potential to be fit for purpose for various applications in various industry sectors.
I was going to say it sounds pretty straightforward, but what are the technical challenges involved in making such a substantial jump?
Yeah, and that's a great question. It does sound kind of trivial, doesn't it, when you first think about it? Oh, they just take a process and they ran it uh, at a higher level format. But my my own experience is that when you make these jumps, the process window itself, in other words, the conditions at which you can get a particular material down successfully in a repeatable way with the right defectivity and all that, um, that's not the work of a moment. It's literally man years of effort to get to that point. Uh, and it will cost many different companies multiple millions or tens of millions potentially of dollars to get there. It's a non-trivial activity. Um, and I would have expected that this process platform would start to narrow. Right now, it looks pretty robust, and I'm going to use that terminology right now. We've got a lot of work to do, but it shows incredibly good promise. And because it's on a 200 millimeter format, roughly half, maybe more, plus or minus half of all of the devices in the world, when I say devices, I mean chips, are produced on 200 millimeter wafers. Um, of course, the AI and high performance compute, those applications are nearly 100% manufactured at 300 millimeters. But we have now a wafer format that we can start to run repeatability tests, uniformity tests, integration tests, and get data that the industry will recognize as being, um, first of all, real, and second of all, scalable. That's what it opens for us.
And just touching on that, how important is that the result that has been announced in establishing a pathway towards the larger format?
So I think it's absolutely critical that we've made this step. It allows us to engage literally with just about every potential device manufacturer in the world, whether they're doing specialty devices that people would classically refer to as MEMS and photonics and et cetera at 200 millimeter diameter. There may be applications for our graphene in those spaces, but it also helps us directly engage with the largest research institutions as well as the primary device manufacturers that are making these high performance compute die, whether it's for AI applications or otherwise, because all of these customers or potential clients have 200 millimeter capability. So what we will be able to do is be able to show results on an industry scale format that we all know how to then transfer processes to the next level wafer format being 300 millimeter. We kind of know what to expect on what the challenges might be and where our process conditions may fall apart. That's science, but then it's also applied science, and then of course it becomes an engineering task. Ultimately, what happens is on 200 millimeter, we'll be able to pattern the wafers, pattern meaning we will be able to create architectures that look like any device that's out there in the world, put graphene into or on it, depending on the application, and get a technical, reliable, and I mean reliability. Does the device function first wafer, first chip on the same wafer, hundreds of wafers downstream, etc. At 200 millimeter, the economics for Adisyn are such that we can do this development work on a wafer level format that is less expensive than going off and buying hundreds, if not thousands, of 300 millimeter wafers, which have a price point, a cost point that's 5 to 10x a 200 millimeter wafer. So we get the opportunity of cycles of learning on a less expensive baseline. That's what it does for us. Of course, we'll still do coupon work, but the bulk of our work is going to transition to this 200 millimeter format because it's industry relevant.
Touching on industry, you'd previously mentioned that the industry's watching. They're interested in what you're doing. They're wanting to see if you can get through the technical gates. A pretty important gate that you've just walked through. Obviously, a lot more to be done. How much more interested do you think industry are in what you're doing and where this could go?
I expect I expect in the industry that this result will surprise in a positive way virtually every tier one client or tier one potential client, whether it's a capital equipment manufacturer, and you can go and look at who makes ALD equipment and can imagine that they would be somebody who would want to engage with our process technology platform. Or you could think about just about any device manufacturer that will be thinking, maybe I can use that in my application set. I think that and I would hazard a guess that 80% of those types of customers and clients would be really energized by this result. Conversely, at the coupon level work, there were a smaller percentage of those same type of clients that would have been interested in engaging as a first mover. But now it's a much broader audience. That's what it does for us. As the press release says, we mentioned several potential commercial relationships, and all of those would be on the table at an accelerated rate at this point.
Just looking at the business and the evolution of the business, obviously what you appear to be building is a graphene deposition process technology platform, and this is one output of that. Is that a fair assumption?
Yes, very much, and I'm glad you used the terminology process technology platform, because what we're talking about here potentially is not just a license and royalty relationship, but also it could be a subscription sort of model where customers have or clients have the potential of not just the license to the original IP and its application on a per wafer or what have you basis, but also they would have access to potentially our engineers, potentially to our development that we do through the next several years for different precursors, et cetera. And that becomes a platform. And there are many business models in the industry that have embraced in that way, whether it's the Sarah application, for example, or the Bosch process, or things like that have occurred in the industry. So it opens a much broader relationship for us.
What happens next, and what milestones should investors be focusing on?
Well, look, we've got I'm going to sound like a broken record, I suppose. This is a first off result. There's a lot of work to be done. And so, for example, we need to explore how repeatable is this process? What kind of uniformity, meaning is it consistently uniform at X number of atoms or X 0.X nanometer thickness across the diameter wafer? We'll have to do, there's a lot of engineering and development work that has to happen so that we characterize this process. Further, we're going to have to be in a position where we've done some rudimentary, at least, reliability testing. And when I say reliability, it means on device or device-like architectures for various applications. We've talked about the interconnect. That's the holy grail. But suppose it's a thermal heat spreading layer, or suppose that it's for in a MEMS application for a resonator, or in the photonic space. So there's multiple endpoint applications that we'd have to have some first order understanding of how does this film hold up. We don't know those. So our precious R&D monies are going to be spent going in that direction. In addition, and so what can they expect? Well, first of all, we're not going to want to let our competitors or even our clients know exactly what we're doing. We're not going to want that. So will we be broadcasting, oh, we've done this, or oh, we've done that? No. That becomes a trade secret that we have to protect. On the other hand, I do expect that on the back of this, that we will have some relationships that are probably on the joint development program level, where we then get access to architectures, device architectures, and capital equipment that we don't have access to right now. And so some of those relationships, when they happen, I'm sure that we will announce. And then, of course, we've got to do a scale up to a 300 millimeter format, with the expectation that all of that previous data that we've gathered and the process regime that we think we've mapped out transports itself to 300 millimeter with the same level of capability. We don't know that yet. So that's going to be a longer term. I think what I would say is let's take this one-time result. Let's do a lot of engineering work, understanding that result, understanding where the cliff edge is, where does it fall apart, so that we map this whole process regime out with data. And that's many months of work. I mean, if you remember many conversations with REA, the team at Adisyn have taken 6 years to get to this point. 6 years. And by the way, that's really fast in this industry. So let's put it in perspective. To go in roughly another year and a half, can we expect that we'll be doing a lot of work at 300 millimeter? Yes, absolutely. But there's a lot of work to be done between now and then.
Kevin, it's clearly an important step for Adisyn, moving from a laboratory scale sample to an industry standard wafer approximately 300 times larger, while establishing a development pathway towards the formats used in advanced semiconductor manufacturing. Congratulations on the milestone, and thanks for joining us.
Yeah, thank you, David. Congratulations to the team. They've done an incredible job and they deserve all the acknowledgement. The announcement's great, but the technical result is really incredible. And I mean, I'm intentionally choose that word, incredible. Thanks for your support and thanks for everybody's interest who might watch this video.